I was asked to do a video on work and rates questions, so I created a problem based on that. So I haven't been able to really find many questions on the old SAT, the new SAT, the ACT, or the SAT subject tests that are of this variety. I found a couple. So it's not a super common question type, and it isn't really necessarily associated with any one particular test. So I just called this a general math video. But I do think, you probably have seen questions like this before. They're kind of a classic word problem. So I think it is useful to know how to tackle these, because even though they may seem complicated, it's actually a pretty straightforward way to tackle them. So go ahead and try this question. John can wash a car in 3 hours, Mary can wash a car in 2 hours, and Rob can wash a car in 6 hours. If they all work together, how long will it take them to wash 13 cars? So the key here is each of them wash a car at a different rate. That's where the rate comes in, right? John takes him 3 hours to wash a car, Mary takes her 2 hours, and it takes Rob 6 hours. And the work comes in by the fact that what they're doing is they're doing some sort of work. They're producing something, they're doing some kind of service. In this case, they're washing a car. And we want to know if they combine their efforts, and if we assume, which you can on these problems, that when they work together or when they work alone, their rates are the same. They just add up, basically, when you put them together. We want to know how long it's going to take them to wash 13 cars. So the trick of this problem is to think how much each person does in an hour. In other words, how much car in an hour does each person wash? So for example, if it takes John 3 hours to wash one car, then if you take that one car and divide it by 3 hours, this is for John, he's going to wash 1/3 of a car per hour, right? The first hour he washes a third of the car, the second hour he washes another third of the car, and then in the third hour he washes the last third of the car. A third, and a third adds up to one car. And we can do this for all of them. So Mary is one car in 2 hours, so one car in 2 hours. In other words, she washes a half a car per hour. And then finally the slowpoke, Rob, washes one car in 6 hours. Why am I writing the word 6? That's weird. 6 hours. So he washes 1/6 of a car per hour. And now here's the key. The problem before is there was nothing we could add. We couldn't add like 3 and 2 and 6 because it didn't really make sense. It wasn't clear how we could add up their rates, but now we have their rate in cars per hour. You just divide, in this case, one car by 3 hours. If they said something like John can wash 7 cars in 3 hours, you would just make this 7 cars divided by 3 hours. It's the same thing. Long story short, you're going to get 3 rates, and now if John washes a third of a car in an hour, and Mary washes a half a car, and Rob washes a sixth of a car, if they combine their efforts, we can now see how many cars they wash in an hour together. And we do that simply by adding the rates. So 1/3 plus 1/2 plus 1/6. And this is going to be the same thing as 3/6 plus 2/6 plus 1/6. So in other words, 6/6, which is 1 car per hour. So it works out really nicely, the math does in this case. If they together wash 1 car per hour, how long is it going to take them to wash 13 cars? Well, it's going to take them 13 hours to wash 13 cars if it takes them an hour per car. But let's say we got something a little bit weird. Let's say we got 12, no, let's say we got like 3/4 of a car per hour. All you would do then is you would take the number of cars and divide it by the rate. So you would divide the 13 cars by 3/4, and that would get you whatever the answer would be, and that would be your answer to that question. So essentially you're going to divide your number of cars by the rate, and that will tell you the amount of time. And the general formula that you'll often see for questions like this is work equals rate times time. So this is like the amount of cars or painted houses or whatever it is you're looking at. This is the cars or painted houses per hour, that hourly rate that we calculated before, and this is the amount of time that is spent doing the work. So this is the equation essentially we're using. You can use this if this makes sense to you. If you're doing distance, speed, and time, you would just make it d equals s times t, or d equals r times t. It's the same kind of problem. It's just a different kind of work, if you think about it. Instead of painting houses or washing cars, you're moving a certain distance. But in any event, that's the equation you could use. And if you rearrange it, you'll get, for example, if you divide the work by the rate, you get the time just by rearranging this formula. And that's essentially what we did in this question, right? We divided the work, which was 13 cars, by the rate, which was 3/4 cars per hour, and that gives us the time. Again, in our question, the rate was 1. I just wanted to make it 3/4 just for a second to show you what you would do if you got a number that you couldn't do in your head. But as we said, the answer to this question itself is going to be 13 hours total.
To learn more about Reason Prep's SAT, SAT subject test, and ACT video courses, go to reasonprep.com/enroll, and you can find the link in the description below the video.